Today on 4.4c, continuing, we're going to be doing trig this whole time. So I'm just gonna tell you for the rest of the semester. But let's say we are given a trig function value. So let's say we're given cotangent of theta equals -3. And then we're given a quadrant, and our quadrant is 2. Our quadrant 2, and we want to find what is the cosecant of theta. So what is that? We're given a quadrant. So let's first analyze this by drawing a picture. It's the easiest thing to do always, at least for me, to draw a picture to know what it is that I'm working with. Okay, so we're ending up quadrant 2, and this is going to be somewhere here then. This angle is going to be somewhere here. Our cotangent of theta. So then if I drew a triangle, if I draw a triangle down, and this is going to be our theta. Our theta is right there. Our cotangent of this theta is going to be the inverse, well, not inverse, it's the inverse of our tangent. So TOA is opposite over, right? TOA is opposite over adjacent. So cotangent is our adjacent over our opposite, right? So cotangent is our adjacent over our opposite. So our adjacent here, well, we don't quite know. So it's our adjacent. So we're going to assume, since we have -3, I'm going to assume it's going to be -3/1. Those are the easiest values for me to use. So wait, our adjacent. So our adjacent, which is -3, over our opposite, which is 1. So now we want to know the cosecant. Well, to do that, we have to use the find Pythagorean theorem. 1 squared plus -3 squared equals, we'll say c squared. So 1 plus 9 equals c squared. So 10 equals c squared. So c must equal the square root of 10. So this is the square root of 10. All right, so let's get our answer now. So our cosecant, I'm going to put here, cosecant must then equal, remember our cosecant is the inverse of our sine. Our sine is opposite over hypotenuse. Cosecant is hypotenuse over our opposite then. So our cosecant must equal root 10 over 1, or just root 10 as our number. Okay, let's do another example here. Let's say now we are given, let's say we're given a sine of theta. Sine of theta is, we'll say, root 3/2. And they want us to find all the possible degrees in both degrees and radians given that sine of theta, right? So let's think about this first. First things first, sine of theta is positive. So the only ways you can get a positive is we got, and remember, sine of theta is our 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 opposite, over our hypotenuse. Our hypotenuse will always be positive. Our our hypotenuse will always be positive. So this means that our opposite has to be positive for this sine of theta to be positive. And let's think about this again. Remember when I told you cosine of theta is your x value and sine of theta is your y value? So our sine of theta is our y value. That means our y value has to then be positive in order for our sine of theta to be positive. Okay, so if I were to draw that, that means if our y value has to be positive, then the angles have to be in either the first quadrant or the second quadrant in order for our sine of theta to be positive. So we have two angles, one in the first quadrant and one in the second quadrant. Now let's see, what does that mean for it to be root 3 over 2? So if I draw a picture here, root 3, so that would be our opposite, root 3 over 2. Well, if I'm dealing with a 2 and a root 3, I know I'm dealing with a 30, 60, 90, and this has to be 1. I'm dealing with the theta has to be 60 degrees. I know that for sure because I'm dealing with the 30, 60, 90. Just drew that triangle. I remember that. So our first one is easy. That one is, this one is 60 degrees. Now I just need to find the other one. Well, if it's 60 degrees this way, I need to go 60 degrees the other way. So I take 180 minus 60 degrees, right, to find the other one. 180 minus 60 degrees. That gives me 120 degrees. So 120 is one of them. To write that in radians, I just use my conversion times pi divided by 180. This should give me a pi over 3 in radians and a 2 pi over 3 in radians. And those are my answers. Remember, you have to analyze uh, whether or not your x and y's are positive and negatives, and um, what quadrant it's in. Let's do an airplane um, example. So let's say we have an airplane. It is coming in for a landing. It is up here. I am not a good drawer, so it's gonna my airplane's gonna look like a fish, but it's an airplane. And it's coming in for a landing, and you're looking at it here. You're here. You're looking at it right there, and the airplane from that distance is 6.1 miles above the ground. It's pretty high, and this is your theta, and this is the distance between you and the airplane. Okay, so we want to find the distance each time. We want to find the distance given theta. So let's say theta equals 30 degrees. Well, we know that we have our opposite, we have our hypotenuse, so we're using sine, right? So the sine of 30 degrees is 6.1 divided by d. So d, our distance, equals 6.1 divided by sine of 30. Punch that into our calculator here, sine of 30. This gives me 12.2. Let's try another one. Let's say the theta is 90 degrees. Ooh, that airplane is way up high in accordance to where you are, straight up above you. 90 degrees is above your head. So that means our distance then is 6.1 divided by sine of 90 degrees, which is 1. So it's actually 6.1 miles. Let's say this is a miles. What about our theta is 120 degrees? Well, that is our distance is 6.1 divided by sine of 120. That gives me about 7 miles. All right, one last example. So let's say we have a formula that says the displacement of the equilibrium of an oscillating weight suspended by a spring is given by y sub t equals 5 times the cosine of 9t, where y is the displacement, so y equals displacement in centimeters, and t is the time in seconds. So find the displacement when t equals 0, 1/4, 1/2. Well, that's easy. All we got to do is just plug it in. So then that equals 0. So then y must equal 5 cosine of 0, not theta. Been writing theta too much. 0, that gives me 5 centimeters. T equals 1/4. Well, that is y equals 5 times the cosine of 9/4. Punch that into my calculator. Okay. 5 cosine 9/4. Be careful when you're doing this that you switch your calculator also to degrees. Press the degree button. Make sure you switch it to radians. Otherwise, you're going to get the wrong answer because we want the cosine of the radian of 9/4 and not the degree of 9/4. And so that will give you negative 3.14 centimeters. And then t equals 1/2. Y equals 5 times the cosine of 9/2 should give you negative 1.05 centimeters.